So we are on lesson 6, spreads of distribution. So we're going to talk about the range and the interquartile range. So first, how to calculate quartiles. And there are different formulas for doing this. And I'm going to show you how these would be a little bit different. So the first thing you need to do is download the R file and get ready to run that. Download the data. So click on this, click File, Download as XLS, and then load the data. So you just click Import Dataset from Excel. I have this in my download file, so you click on that and then click open. And then on the lesson 6 code, we're going to need those two libraries. And one thing that you can do is sort. We're looking at the female pulse rates to start. So you can sort these. So I use that to sort the data values here. And then I'm going to talk about how to find these. So here's the sorted ones. You won't see that. So it's easy to see the minimum is 62. The maximum is 75, and then here there's 10 data values. So in between the 5th and 6th one, so 1, 2, 3, 4, 5, we would find the average of 69 and 70, which is going to be 69.5. And then here to find the first quartile, it's going to be between the 2nd and the 3rd data values. You find the average of 65 and 67. So that gives us, well, 66.5 if you did it that way, or 66. So the average between those two would be 66. And then here, for this half, a lot of times what people will do is split that up, and then we have half above, half below. And some people will say here, well, this is actually the middle here is 67. And then here for the 3rd quartile, the middle here is 71. However, we're going to notice that R uses a little bit of a different formula to calculate that. So your quartiles will be a little bit different. So that's why we're just going to use the summary function, and you're fine with using that. So here, the first quartile is actually 67.25, and the 3rd quartile is 70.75. So I'm going to put that in here, 70.75, and then I'm going to go back and put 67.25. And then if I wanted to find the range is a maximum minus a minimum, so 75 minus 62, which is 13. And then the interquartile range, you go Q3 minus Q1, so 70.75 minus 67.25, and that gives me 3.5. And then you can always draw a box plot with those numbers up here, and I'm going to show you how to do a box plot with R. So you can just do box plot of the female pulse data. Horizontal is true. We can add color if you want there. We can put the color to be blue, so COL equals, and then we would just put in quotes blue, and that will actually add some cool color to it. And then you can also add titles if you want. So the main here, and my face is over it, is just like female pulse rates. So now for task 2, what we're going to do is find the mean of this systolic blood pressure reading. So here, another measure is the mean absolute deviation. So we're going to look at these blood pressure measures, find the mean. So I did that. The mean is 122.4. So I'm just going to grab that, copy it, and then what you would do here is put in 122.4. And then here you would just subtract each of these, 135 minus 122.4. And then let students do that. But then you can also show them, like, honestly, to make your work a little bit easier, that is what R does. So you can find the deviation by doing the systolic blood pressure minus the mean of the systolic blood pressure. And that gives you these numbers. So they would just put them down the column in order. And then to find the absolute value of the deviation, you just do the absolute value, ABS, of the deviation. And then there are those numbers to find the absolute deviation of that. And it lists them in order. So then they would just go to this column and fill that in. And then the mean absolute deviation, they would just add them up and divide by how many there are. And then you can do that as well by doing the mean of the absolute deviation. All right, so then what we can do for the next one is calculate that mean of the absolute deviation directly. Let me see if that does that here. Where there is the MADSTAT of, it's going to go L6 data hashtag systolic one. And then that also does that. The MADSTAT function, I think, is in the IE2 MISC library. So you can find those in there. So we did the mean, all of those, found the mean absolute deviation, and then you just put those numbers in there. And then to compare some data sets, we can find the mean of each runners and then find their mean absolute deviation. Who's faster? Who has a smaller mean? And then whose data is more spread out? Who has a better mean absolute deviation? So here we did Regina's average. And if you notice, I can get that to print out by putting parentheses around everything. Her average speed is 30.3. And then we could do these to calculate the each of those, like the deviation from her mean, and list those and take the absolute value, and then do the mean of that. Or you can find the mean absolute deviation is 2.3. And then the same thing for Erica's times. Her average is 29.9, so she's faster. And then we can find her mean absolute deviation. Remember, the other runners was 2.3. I did the MADSTAT here. It is 1.32. So she is a little bit more consistent. So now what I want you to do is calculate some of those statistics by hand, and then also use R to make your job a little bit easier.